Welcome to our video on atomic structure. Hello, my dear students. Today, we are beginning the first unit of our AL syllabus, atomic structure. In this unit, we will discuss several key topics. The atomic theory of matter, electromagnetic radiation and its wave-like properties, electronic energy levels of atoms, electron configuration, the building of the periodic table, periodic trends shown by S&P block elements. Under the atomic theory of matter, we will delve deeper into properties of cathode rays, experimental observations, the nucleus of the atom, properties of positive rays, experimental observations, Rutherford's gold foil experiment, atomic number, isotopes, and mass number, the atomic mass scale, average atomic mass and relative atomic mass of an element, ions. First, I would like to ask you, what is chemistry? Chemistry is the study of the properties and behavior of matter. Matter is the physical material of the universe. It is anything that has mass and occupies space. From the earliest times, humans have tried to understand the universe and what it is made of. Early philosophers, including Empedocles, for 40 BC, Democritus, 460 to 370 BC, Plato, and Aristotle, as well as notable scientists such as John Dalton, 1766 to 1844, George Johnstone Stoney, 1826 to 1911, Sir William Crookes, 1832 to 1919, and J. Thomson, 1856 to 1940, all attempted to answer these questions. Empedocles and Hindus believed that the world is made from four elements: earth, fire, air, and water. However, Democritus and other early Greek philosophers described the material world as being made up of tiny, invisible, indivisible particles that they called atomos, meaning indivisible or uncuttable. However, Plato and Aristotle argued that there could be no ultimately indivisible particles, and the atomic view of matter faded for many centuries. In 1808, the English scientist and teacher John Dalton formulated a precise definition of the indivisible building blocks of matter that we call atoms. Dalton's atomic theory can be summarized as follows. Elements are made out of extremely small, indivisible particles called atoms. All atoms of a given element are identical in mass and size, but the atoms of one element are different from the atoms of all other elements. Atoms of one element cannot be changed into atoms of a different element by chemical reactions. Atoms are neither created nor destroyed in chemical reactions. Compounds are formed by the union of two or more atoms of different elements in a simple numerical ratio. Have you heard of the word electron? George Johnstone Stoney introduced the concept of the electron, the fundamental unit carrying electricity. Sir William Crookes invented the Crookes tube or cathode ray tube. The Geissler tube, which employed low pressure, but higher than the cathode tube, is the predecessor of the cathode tube. In the cathode tube, higher vacuum conditions are employed. Crookes conducted experiments with the cathode tube and observed a stream of invisible radiation. Although the rays could not be seen, their presence was detected because they caused gases at low pressure to glow and made other substances fluoresce, or give off light. The radiation emitted from the cathode was named cathode rays. Later, it was discovered that these rays could be deflected by a magnetic field and carried a negative electrical charge. J. Thomson observed that cathode rays are the same regardless of the identity of the cathode material or the gas in the tube. He described cathode rays as streams of negatively charged particles. Here is a figure of his cathode tube. The negative end of a higher voltage source is connected to the cathode, and the positive end is connected to the anode. He used a cathode tube with an anode that had a hole at the center. Using experimental measurements obtained from that cathode tube, he then calculated a value of 1.76 times 10 to the power of 8 coulombs per gram, Cg to the power of -1, for the ratio of the electron's electrical charge to its mass. Thank you for watching. Let's meet in our next session, where we will continue exploring the wonders of chemistry and atomic structure. Don't forget to like, share, and subscribe for more educational content. See you next time.